Awesome. We can keep chatting on this, for a very long time, and I want to make sure we are able to get through some questions, as many as we can. So I'm gonna, not in any particular order, take the first one. It seems to be a fellow from Michigan, along with me. So our assumptions made on the road conditions in Michigan potholes pop up after winter. The gist of the question is, how do we differentiate between a map that is released before and a new map, right? I mean, changes happen pretty dynamically. Um, can we detect such changes, on board, or do we have to release a whole new, kind of map to handle this? So while I've directly managed mapping teams, so I'm not going to take this at first hand. Nick, do you want to go on this because you had mapping as one of your portfolios before?
Yeah, that's right. Yeah, this is a challenging one, I think. However, like internally, I think whether it's potholes or in particular construction zones are probably the key thing where, you build a map, you deploy it to the vehicle, and then all of a sudden they've shifted lanes to the left or completely in a different direction. And so I think you do have to have a sensor that, or I mean, a system with sensors, of course, that recognizes that and sort of alters the map in real time. And so I think, yeah, I mean, we have this type of technology that sees that, hey, there's Jersey barriers or there's cones, there's pylons that have shifted the lanes, and on the fly. Allowing our vehicle to navigate through there. In certain situations, if it's completely out of our operational domain, we might say, well, we're not going to allow the vehicle to navigate through there. So that's where, having these off nominal detectors allowing us to avoid these pull for the time being until we are able to develop those capabilities, I think is key.
Right.
I mean, I will say that, I don't want to say for sure about like potholes. I certainly know our sensors detect them. That's not necessarily a part of the map, though, at least at Aurora. I mean, that's just something that our sensor system is going to have to detect and then allow our behavioral system to deal with.
Right, right. I mean, there are different layers in the map, right? There are static and dynamic layers. You can adjust for those situations in the dynamic layer. And I think at the end of the day, if you're not able to handle a situation, you again, as we said before, take a graceful exit and either reroute the system, to go somewhere else, or kind of pull over and have your, field ops kind of take care of it. So there are different ways in which we do it. Also depends on if it's a commercial trip per se versus a testing. Testing can, have a different acceptance trigger compared to when you actually have a product out, commercially operating. Good question. Let's move on to some of the other ones. Melinda, maybe you can take this one up. So we have talked a lot about engineers using simulations to collect data. Do you conduct any HRI testing in simulation with customers? Seems safer than testing a model or product in the real world while still getting user feedback. So I believe HRI probably means human resource or human interaction, UX UI testing.
Yeah.
In simulation. Yeah. You want to
Yeah,
take that?
I'm actually not familiar with the term, the HRI acronym, but I can certainly address the types of testing that we do. Simulations to conduct data. Yes, that's 100%. And I think when I was talking about shifting testing to the left, that's exactly right, because it is much safer and easier and cheaper in a lot of ways to collect data offline, meaning in simulation, with or without hardware in the loop, than it is to go drive either in a closed course or on public roads. And so there's just, I think, only upsides to doing more simulation. And certainly that's where I know Nick has talked about this too, where a lot of the data that we use for testing is coming from, both for kind of day-to-day development testing. So myself as a development engineer, I use simulation, a lot to test my features before even thinking about doing on-road testing, but then also at kind of a overall software release cycle testing as well. So thinking about how are we just, testing all the different pieces of software coming together, the integration testing, and then of course, when we're thinking about acceptance and release testing, simulation is a huge part of that as well.
Right. No, well said. I mean, specifically also about the user experience research testing, there are teams within organizations who conduct, UXR, UI testing, where You have the product, you sort of emulate the workflow of, for example, if you're ride sharing like a robotaxi, then, you kind of do it using the app. You call the vehicle, you have the vehicle stop, you get in, you do all the sort of ConOps checks, and then you're ready to go. And then you kind of have the trip status, and then, kind of end it. So there are a whole bunch of, different, uh, if not simulation in terms of digital simulation, there are emulation workflows which will help us to understand the whole end-to-end product workflow. And there's a lot of work that happens naturally as a part of, your commercial model development. Awesome. So next one that we would take is on traceability. So for complex system, traceability is always an issue. Are there any best practices that can be shared on this one? Nick, do you want to take the traceability question? Maybe the matrix that we can use between. Yeah.
Sure. Yeah, let's see. I think on traceability, I mean, I absolutely think that I mean, that's critical to get right. I think maybe I'll just speak to some of the challenges that we faced over time. I mean, and to start, but I think because we've been talking so much about the iterative process of this, where we're constantly learning and making adjustments. And I think for the taxonomies or hierarchies that we are using in order to add metadata to the analysis that we're doing, over time we start to change some of those frameworks for the better, right? And I think the traceability of those changes is incredibly important. And we run into some obstacles in the past where even just a simple name change, like maybe safety says or legal says, hey, we prefer if you use this other terminology, and we make a simple name change, that can actually have a huge impact later on as people are starting to try to pull in data and look at trends and insights over from the past. And so it's vital that you have sort of that change management and mapping over time. One way to do that is potentially using some kind of unique IDs that are sort of durable over time. Even if you're changing certain language and whatnot, you've got some durability so that you can pull data and still have access to what has changed. But I will admit that it's a crucial call out on your part, and it is a very difficult problem to face, and it's a really important one to tackle, though.
Right. I think the evidence of that all the way goes into your final safety case, where you kind of show the test coverage, your testing traceability matrix from your requirements to the testing and output and so on. So just a quick check on the time. We've got a couple of minutes to go, so I'll probably take one last question and then we can take a wrap here. There are a couple of questions around a similar theme, so I'm not going to pick one specific question as such. But Melinda, what about the sort of redundancy in the system, right? When it comes to handling certain, I mean, of course, you have Autonomy to be your, the sort of champion of everything. Can you talk about the different layers of redundancies we can build from Autonomy all the way down to your on-the-ground operations, and how what's it that?
No, I think that is redundancy is the thing we're trying to build. I think this is a common I guess analogy or model for kind of thinking about risk management, but kind of the Swiss cheese model, right? Where any single thing that you're trying to do to manage risk has holes, just like Swiss cheese. But if you stack enough layers of the Swiss cheese together, you build kind of a solid piece that doesn't altogether does not have holes. So I think of it exactly, redundancy is exactly what we're trying to do there. And it starts really at the autonomy level. Of course, we have at Motional, certainly we don't just rely on one single sensing unit, both in modality and sensor itself. So instead of just using a single camera, right, we have surround cameras, we have 7 cameras or however many cameras we have, LiDAR, radar, we kind of have redundancy in that aspect. And then that kind of translates, of course, to our online decision making, having redundancy in there that we're not going to miss a detection because they're different sensing modalities. Right. But then, of course, kind of in our overall operations too, I think there's a lot of redundancies built in intentionally to protect against this. And I think one of them, is actually, we've talked about this, but the whole test process. There are at Motional, and I'm sure hopefully all autonomous vehicle companies, pretty strict policies on, you know, what's the process to actually get code running on a vehicle. And it includes, you know, mandatory checks of simulations have been done, and hardware in the loop has been done, and, you know, checklists of processes that are designed with redundancy in mind to keep everyone safe and to, you know, ensure that we're doing the best thing. So I think redundancies are built in, like you said, you know, from ground up, really.
Right. That makes sense. I mean, all the way from your own autonomy platform redundancies to your, you know, forward collision warning, AV, you know, sort of systems which exist on your, you know, fundamental base platform. They all contribute to a, you know, sort of a acidification per se, right, of your whole product.
Yep.
Good stuff. We can keep chatting more. We can keep having this, you know, more in-depth discussion, but I want to be respectful of everyone's time here. So we're just on the clock. And I want to say, you know, a very a detailed thank you to both Melinda as well as Nick. You know, thank you for being here, for participating in this, you know, enthralling discussion. And I'm sure we'll cover more topics. You know, some sort of this combination of team will come back again on the Fireside Chat series. Any closing comments, Melinda, with you first and Nick, and then we'll wrap it up?
Yeah, absolutely. Just a big thank you to Sahil and the whole Digital Divide team. This was really fun, and I hope informative for the audience as well.
Yeah, likewise. Yeah, you summed it up nicely. I appreciate everybody here, and I look forward to attending and listening in to future talks for sure.
Absolutely.
Good stuff. So the next talk we're going to have is going to be about simulations and how do we use, you know, how do we take the most out of simulations, which is some sort of a segue from this discussion into, you know, development of autonomous vehicles. So more to come. And Preeti, anything else before we wrap up?
No, just want to thank the team for joining in and, you know, giving us such good insights about the performance valuation. And yes, we'll look forward for more such sessions.
Awesome. Well, spread the word. If you have your friends, colleagues, other people who want to join for these future chats, keep watching our LinkedIn. And again, a big thank you, Nick, Melinda, Preeti, for organizing. Have a good one.
Thank you.